Hi, welcome to my video on circles, inscribed, and central angles, and arcs. And this is number 4. Number 4. I have a circle drawn, and O is the center of the circle. AB is a chord of the circle. A chord is a segment drawn from one point on the circumference to the other. That means that AB is a diameter, because a chord that passes through the center of the circle is a diameter. As a result of being a diameter, we know this is a straight angle, and it's 180 degrees. So let's follow what I've set up. The angle AFB is an inscribed angle intercepting the arc BTA. So this inscribed angle is intercepting this arc. And notice I named this arc with 3 letters, because if I said AB, it could be this one or it could be this one. So I named it with an extra letter in the middle to identify it as BTA. And the arc BTA is 180 degrees because this is a diameter. A diameter is a straight angle, 180. This is a semicircle. So this angle is a semicircle, which is 180 degrees. So the angle AFB is a half of this intercepted arc, because it's a half of 180, because an inscribed angle is half of the intercepted arc. Not only that, it's also a half of the angle AOB, which is the central angle. So this inscribed angle here is a half of this arc, or is also half of the central angle. So both are 180. So this is 180. Both of these, either one of them, you pick the arc BTA, or you pick the angle AOB, you have 180 for either one, and a half of 180 is 90. So again, this angle here is a half of the intercepted arc here, or half of the central angle. So this angle is 90 degrees. So let's look at the other inscribed angle, BTA, or ATB. You look at ATB or BTA. Take this angle here. This is an inscribed angle intercepting the arc AFB. And the angle the arc AFB is 180 degrees because it's a semicircle. So this arc being a half of the semicircle, so the angle ATB is a half of the arc AFB, or it's a half of the central angle AOB. So this inscribed angle is a half of this arc, or half of the central angle. And again, the central angle is 180. This is 180. So this angle ATB is a half of 180, which is 90. And again, this is an inscribed angle subtended by this arc, or intercepting this arc. So we have a property that's used all the time, and the property is an inscribed angle intercepting the diameter. If an inscribed angle intercepts the diameter, then it is a right angle. In other words, the angle is 90 degrees. When we say, notice the inscribed angle is intercepting the diameter. So the inscribed angle is cutting off the diameter, and the diameter is 180 degrees, so that's why it's 90. This inscribed angle is intercepting the diameter. So this inscribed angle is cutting off the diameter. So it's 90 degrees. And that goes true if I drew this angle to this point. Let's call this point G, and I joined it to B. So this angle AGB, that would be 90, because it's intercepting this arc, which is 180, or is subtended by the diameter, is cutting off the diameter, which is the central angle making it. So all the angles that I draw from A to here over to B, all of these angles will be 90. So if I draw this angle, B down to the circumference to A, so this is an inscribed angle intercepting this diameter. So this angle is 90. So it's another way to say it sometimes, the inscribed angle is inscribed in the semicircle, 90 degrees. So let's do some examples or practice on using that property. So O is the center of these circles. I want to state that instead of statement for each one. AB is the diameter for each of these circles. So let's work these out. What we have is this is the diameter, and notice that A, this angle here, is inscribed off the central. So that means that X is 90 degrees, because this inscribed angle here is intercepting the diameter, which is 180, so half of 180 is 90, or is intercepting this arc, which is 180, so that's a 90. And if that's a 90, then 90 plus 50 is 140. So a triangle got 180 degrees. So the other angle is 40. So this angle is 40. And besides that, if this angle is 90 right here, these two angles are adding up to 90. Because if you take 90 away from 180, you get a 90. So the sum of these two acute angles must be 90. So 50 plus 40 makes 90, because that's a 90. Number 2 is using the same property again, and I have a diameter. That's the center of the circle. This is an inscribed angle, angle B, and let's call it T. Angle BTA is an inscribed angle made up of two chords. This angle is 90 degrees because, again, it's intercepting the diameter, or this inscribed angle is half of this arc. So that's 180. This angle is 100. Central angle is 180. So this inscribed angle is half the central, or this inscribed angle is half the intercepted arc. So E is 90 degrees. Now we have these two segments equal. So AT equals BT. That means that we got an isosceles triangle with two sides equal. That means we have two angles equal. So this is a 90. These two angles add up to 90, but they're equal. So that means that 90 divided by 2 is 45. So F is 45, as well as this angle is 45. So two sides equal, these two angles are equal. 45 and 45 make 90, along with this 90 here. Okay, continue. We have another one to do based on this property. O is the center of this circle, and that means it's understood this is going to be a diameter. It didn't say that. So if O is the center of the circle, we're assuming that this is a straight line here and it's not curved. So that means that KH is a diameter in order for this to work. So we've got to find the measure of the arc KT. Well, if this is a diameter and this is an inscribed angle, the angle KTH is inscribed because it has two chords with a common vertex. So that means that 3x is equal to 90 degrees, because this is the inscribed angle intercepting the diameter. So this is a central angle, 180. Half of 180 is 90, or this is an inscribed angle intercepting this arc, 180, half of it is 90. So if 3x is 90, x divided by 3x is 30. So if x is 30, angle K is, remember I want to get the arc KT. So to get the arc KT, I'm looking to get this angle here. That's one way to do it. So let's get angle K is x plus 40. So x is 30 degrees plus 40. That's 70. So this angle is 70. This angle is 90. So the angles of a triangle add up to 180. So angle H is all the angles add up to 180 minus the 30 minus the 70. So that's 100. So that means that we have, oh, did I say 90? I meant to say that I was putting x in. It's 90 plus 7. This angle is 90. This angle is 70. So 70 and 90. So that's 160. So we have a 20. I was putting the 30 in here. I should be putting the 90 and the 70. 160. So angle H is 20 degrees. So that means that we have the inscribed angle. So angle H is the inscribed angle. So the measure of angle H is a half of the measure of the arc KT. So angle H is 20. KT, it's like a pi. So we double it, 40. Double a half is 1. So the arc KT comes out to be 40 degrees. 40 degrees. And it makes sense. If the arc KT is 40 from here to here, then the inscribed angle is a half of it. So if I have the inscribed angle and I want the arc, I have to double it. If I have the measure of the arc, the inscribed angle is cutting off, then I take a half. So the inscribed angle is a half of 40, or the arc is double the inscribed. And another way to get that too would be if this angle is 90, this is 180 from here to here. Because the inscribed angle is half the arc, so the arc got to be 180. If this angle is 70 right here, this inscribed angle is cutting off this arc. So here's the inscribed angle cutting off this arc. So that's 70. This is 140. So if you add all these up, you get 360. So a triangle is inside with 180 degrees, and all these angles, because the triangle vertices of the triangle are on the circle, because the vertices are lying on the circle, the sum of these angles in here is 180, and the distance around here, the measure around here, to say distance, is 360. So the angle of a triangle is half the measure of the circumference. And we have another one to do, number 4. Again, O is the center of the circle. I name O as the center of all my circles. PT is a chord. Oh, a PT is a chord. That means it's a diameter because it's passing through the center. Okay. Now we have PV is 60 degrees. So the arc PV right here is 60 degrees. We have PT is 6 root 3. So PT is 6 root 3. And this arc, PV, is 60. And because this is a diameter, then this angle right here is 90 degrees. Because this inscribed angle intercepting the diameter is 90. Half of 180 is 90. Half of the arc is 90. This arc is 180. So we have a 90 degree angle here. This arc is 60. So if this arc is 60, it's this angle VTP is intercepting this arc. So that means this is an inscribed angle being 60, because the inscribed angle is half the intercepted arc. 90 and 30 is 120. This makes this 60. So we have a 30, 60, 90 right triangle. So I'm going to draw that triangle right here. So we have a T, P, a T, and a V, where we have a 90, a 60, and a 30, and this is 6 root 3. Now, the triangle that goes along with that, so I'm going to draw another triangle. So we have a 60, and we have a 30, and we have a 90. So this is a special right triangle. Opposite the 30 is n, opposite the 90 is 2n, opposite 60 is n root 3. So what we have is that if you look at it the way I do it, I match that 2n is equal to 2n is pt, so this is matching up, so that means 2n is 6 root 3. So divide by 2, n is equal to 3 root 3. So we have n is 3 root 3. So that means we have this side is 3 root 3. And PV here is n root 3. That means we know that n is 3 root 3. Multiply root 3 times root 3 is 3, so 3. Root 3 times root 3 is 3. 3 times 3 is 9. So we have, this is 9 here. So the perimeter of the triangle is the sum of all the sides. So this is a 9. This is 3 root 3. So we match them up. So the perimeter is 3 root 3 plus 6 root 3 plus 9. Add. Root 3's can add together. So 3 plus 6 is 9 root 3 plus 9. That's the exact parameter of this triangle. So notice I drew a triangle similar to it with n, 2n, n root 3, matched up the sides, and then added them to get the parameter. Perfect problem. Math always comes back. You need to understand the basics in order to do the math. And as you go higher in math, you have to know the basic concepts and work them out. Be able to do the heavier math. And if you like my video, click the like button, click the subscribe button. If you wish, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained. Notice just one word for Math Fully Explained. Thank you for viewing my video. Hope the video helped you. Bye-bye.